Hello all and welcome to my new video. At the beginning of this week I had some new releases. So two of my projects have been released in new versions. PE-sieve and Hollows Hunter, that is also a scanner based on PE-sieve, so it's kind of a wrapper for PE-sieve. And in PE-sieve I added several functions, but I think the most interesting function of this release that requires a bit longer explanation is this and the one that allows to dump a payload in different modes, and also I have auto detection option. So I will explain today what it is all about and why do we really need these different modes of dumping payloads, and how it differs from the previous versions. Let's start from this that different packers may have their own ways of unpacking payload in the memory. And in the past, I was focused on mostly on this type of unpacking that is used for the process hollowing or for process doppelganging, where you map the full PE in the newly allocated space in the memory, and you redirect the execution here. So you map it just via virtual headers of the sections, and then you jump there. So for this type of cryptors, it's the best just to grab this section from the memory and just unmap it so that we can load it via normal tools to analyze it further. Due to the fact that PE-sieve is growing and it's expanding to various different areas, it started to be used in some other open source projects also to, for example, detect malware by some patterns found in code. I found it not sufficient to offer only this one type of payload unpacking. So I started experimenting about different options. And for example, what I mean by different type of unpacking, when is it required? For example, we may also have some packers, some protectors, sometimes custom ones, sometimes the ones that are used for non-malicious purpose too, and they not really use the same injection methods as those that I mentioned before. They don't unpack the full new PE file into the new section in the memory, but just they modify the sections of the existing executable of from where this from where all this application has been deployed. For example, UPX is a general purpose executable packer, and in this case we can take a look on the sections and on their virtual and row alignment, and we can find that the first section it's filled in the memory, but we cannot really unmap it back to row because of the fact that the stub already unpacked this section and put in the full content here. So if we dump it from the memory, we will not really see this this newly added content, because this newly added content does not correspond to any row section. So if we unmap it, we fully miss it. And yeah, this was one of the problems, that there are some malwares that also unpack their payload in a similar manner. For example, this is Trojan Mecotio, and the malicious DLL that belongs to this Trojan is packed also in this way that the initial sections are just 0 in raw format, but then they get filled by the unpacking stub, and they are the ones that contain the real code of malware. So if we try to search any familiar patterns that we know that they are related to this malware in the unmapped dump, we will not find anything. We will still have only this unpacking stub and nothing inside. This was one of the problems that I was considering, and I will show you briefly the examples, and we will see how it really works, how it is mapped in the memory. But I will also like to show you yet another example, which shows yet another case where different modes of dumping can be used. And this is a reflective DLL. This is a original proof of concept of reflective DLL along with the loader. However, the reflective DLL injection is a method very often used by malware authors, and yeah, we can find it on daily. We can find some malware that use the reflective DLL injection. And for those of you who don't know how it works, in case of reflective DLL injection, first of all, there is a stub reflective loader that contains just the full PE loader, and it's built in this DLL. And we can see the exported function. And this exported function is supposed to again load itself, but in the virtual format. Because first, when the injector injects this type of DLL, it injects it in a raw format. But due to the fact that it injects it in executable memory area, this raw format can execute. And when it injects it, it sets as an entry point to this injected area the raw address of this reflective loader stub. So this loader is first executed from the raw DLL, and then it copies. It sets the beginning of this raw DLL, allocates again memory for it, and once it allocated memory for it, it remaps it to the virtual format, and then it goes to the original entry point of this DLL, so that the DLL can normally execute. So we are getting in reality two copies injected in the memory. One of them is raw and one of them is virtual. So the old model of unmapping that was used by PE-sieve was only able to reconstruct this this PE in virtual format, but this one in raw format was getting corrupt because there was no detection when to unmap and when it is not required. We were getting something useful, but we were not getting the exact thing, because sometimes it happens that when the DLL, when any PE file starts to execute itself, it may override some other sections with some data. Sometimes some data is decoded, sometimes something else is being modified, and we cannot have a guarantee that the PE that we dump from memory will run properly. We cannot have guarantee that it will run exactly as the one loaded by Windows Loader from the normal raw image. So it's imperfect copy that very often it runs, but well, it depends. It depends on the particular case. We may have luck or we may not have. So it's always very useful to have this raw copy also, because this one is the most valuable. This is the one which does not have anything modified, and we can just use it freely. And I will demonstrate you maybe now some examples on how exactly it works. I have here a PE-sieve in the new version. It is version 01.5, and I have also a Hollows Hunter here. And this is the version of Hollows Hunter that I'm gonna use. It is 01.8, using exactly the same PE-sieve. And yeah, I think I will start from showing you how it works on reflective DLL. This will be my first test case. Okay, so I ran the injector, it injected itself. And now let's try to dump. Let's try to dump it via PE-sieve and see what our latest release of PE-sieve can dump for us. It dumped two different, well, not really different, but two specimens of the payload, and you can see both of them looks the same, and there is also overlay. I'm not removing the overlay in case if the payload was not unmapped. I'm just leaving it as it is. So we can see that one of those payloads was this raw format and the other one got unmapped. Yes. And can we reuse this to show whether what is dumped is really running properly? It should, but just let's prove it. I will take first the version that got dumped from the raw and rename it. And let's run the injector again. And you see it works. We can reuse this dumped DLL, dumped from the raw format, and it works perfectly fine. Will it work fine also from the virtual? Let's take a look. It may, but it is not, there is no guarantee, and you see it doesn't in this case. So we can use it, unfortunately, for static analysis only, but we cannot run it. But now we have also a copy that is just a fully working dump, and that's what we gained by this method of having two different dumps. So raw worked, virtual didn't work, and I will run again the original example. This time the PE is 608. Yes, it dumped again. Dumped properly again, because I didn't change the mode. It was on the automatic mode. That is default. But I gave to a user also a control to choose manually in which mode you can dump it, because maybe in some cases the auto detection may fail. I hope it will not, but I think it's always good to give some manual control to a user just in case. And here I will use this manual switch to dump it in the unmapped mode that was used in the past as the only mode, and I will show you what is the difference, that in new mode both payloads got dumped properly, and in the old unmap only mode only one of them. Sorry. The mode unmapped, so it's second one. Yeah. So let's reload it, and you see this one, reload both. This one that was mapped in the memory, so the virtual copy got unmapped properly, but this was the one that couldn't run because it already got some data overwritten. And the other one that was raw in the memory, in that previous mode, in unmap mode, it couldn't get unmapped properly because it got unmapped with the assumption that it's already virtual, and it got simply corrupt. So I just fixed it now in the new PE-sieve, that it doesn't make any assumptions, it just check first some indicators, what exactly it is. And this is one of the benefits of this new version, but there are more. As I mentioned, it can manage also in the cases like the UPX case, where the full section is written in the memory, but it's not like PE is loaded, the PE payload is loaded as a separate entity. This just section is unpacked. So this is my test case. It's just a PE unmapper, my other tool that I packed with UPX. Yes. And let's run PE-sieve on this. And we can see it unpacked it. Okay, also imports should be fixed. And we can see that the sections now it have been unmapped as realigned, so and the virtual format, the raw format, has been converted in a way that it's aligned exactly in the same way like in virtual. It's done so that no content that is written only and which only in a memory and doesn't have the equivalent in raw headers can be just dumped and nothing is lost. So yeah, I will show you how it works. And among the things that I don't currently have is, for example, I don't search in this case original entry point of this unmapped PE. So the entry point stays as it was in the headers. I also don't have rebuilding of the new import table that has been loaded in the new location. I think I will implement it in the future, but for now I just reconstruct section content and this type of payload will not run because of this. However, we can use it for some static analysis to also to see some. Oops, sorry, not this option. Search for string references. Nope. Maybe it was. No, for some reason it doesn't give me the exact thing that I wanted to see. Okay, so we can see that in this unmapped image there are strings that are actually used by this PE unmapper. It cannot run, but we can use it for some pattern detection, for some static analysis. So it gives some additional information that was missed before, and obviously this feature will be improving. Now I will show it also on some malware, and I think I will use the Ramenit sample as a demonstration. Okay, I suspended it so that it will not terminate. And let's scan it and see what it has inside. Okay. This was also packed with UPX. And yep, in this case we can see those functions that got unmapped in the memory. We can analyze them statically. Let's see what we can dump from the sub-processes. So here there are two things dumped. The first loader and the second one, that is a module. Here is a different module, but we can see that there were two modules. For one, the most suitable option to unmap it, that was detected via auto detection engine, was to realign the payload, because it was packed in the same. It was basically packed with the help of UPX, so section got overwritten in the memory, and that's why by realigning it we preserved the code that was unpacked. And the other one was just unmapped because it was fully loaded. The full DLL was loaded in the memory, in the new memory area as a separate entity, so no section modification, but full DLL loading was done. What more I have from the interesting demos, and this is a Trojan. This is a banking Trojan called Mekotio. It has two modules. Well, the first module is a loader, and it's a legitimate application, but this legitimate application have one DLL hijacked, and that is sh folder, and this module, this sh folder, is in reality the malicious module. Even it exports one of the functions exactly like sh folder, but you see it's something entirely different. And why it's interesting? Just because of the way in which it is packed. It's packed also in the way that sections are fully filled in the memory. So I will kill this. And run this module. But as far as I know, it will die very fast after being deployed. So, because it will detect my VM, but still it will unpack before dying. So I will load it in a debugger. It throws exceptions, and I don't have here a plugin that it have some anti-debug features, so I will use Oli because I have plugins already pre-installed to mitigate it. So okay, the loader got terminated, as it was supposed to. And here I will run it as administrator. 3048. And you can see it dumped this DLL, detected that this DLL was the one that it is supposed to dump, and it dumped it in a realigned form. So all those sections got filled. And we can see in the raw format, before the sections were unmapped, we couldn't go to these functions, but here it's possible to go there. Because the section got already unpacked. And let's say we can see those functions, or we can even set entry point here. Change it to executable just for the test. Let's take a look if we can see clearly the content of this function now. Well, still it seems obfuscated. But it's better than it was before. Because we can go through this code. So this is the way in which it got dumped from the memory. We can now proceed a bit with analysis of this module. So that's all what I prepared for today's video. I hope you will also do some experiments with those new features. You can use by default the auto detection mode, and it should be fine. You can also experiment by changing switches, and of course any feedback is welcome. If you will find any bug, please let me know. If you will find also if you will have also some ideas for improvement, and don't hesitate to write me or make an issue on GitHub. Thanks.